Hello students and friends. In this video, let us discuss Bouveault Blanc reduction and Acyloin condensation. These two reactions are slightly similar. That means here, in these two reactions, sodium metal is common. Sodium metal, ethyl alcohol, here sodium metal and xylene. This xylene is a non-polar solvent. This ethyl alcohol is a polar solvent. It is a Bouveault Blanc reduction and this reaction is a Acyloin condensation. So here, what is the role of this solvent actually? The main difference here, using solvent, you will get the different products. So here is a Bouveault Blanc reduction and this is a Acyloin condensation. In Acyloin condensation, this alpha hydroxy ketone is the product. In this case, ester is reduced to alcohol. Okay, as in the case of lithium aluminum hydride reduction, this Bouveault Blanc reduction takes place metal in presence of the polar protic solvent. Okay, this xylene is a non-polar solvent. That means here in this case, this CH3 and of course here xylene means here that may be paraxylene. Okay, this is a non-polar solvent. Or maybe metaxylene or maybe paraxylene. All those are the aprotic solvents. Okay, aprotic solvent. Now here, this is a Bouveault Blanc reduction. Okay, so here in the Bouveault Blanc reduction, this ester molecule gives a alcohol. So actually here this carbon carries a positive charge. This sodium release electron. Okay, the sodium release electrons. This electron attacks on this positive charged carbon. So by gaining of electron, that becomes a radical. So here electrons are transferred to oxygen, so it carries a negative charge. And now this negatively charged oxygen accepts the proton from the protic solvent. That is the main feature of this ethyl alcohol using. So that becomes a radical. Now here in this case, again this sodium gains another electron. So that becomes a anion. Okay. Why? Because this radical in this case cannot gain the second electron from the sodium, because if this gains electron, this becomes a negative charge. Already here there is a negative charge, so there is a more repulsion, so that dianion formation is not possible. That's why this anion gains one proton. Then here this one is ready to accept the another electron from the other sodium metal. So by gaining of electron, that becomes a anion. Again this one accept the proton from this one. We get this product. And here this compound, he is unstable compounds. Here just here loss of that alkoxy group takes place, RO minus, and here from this one H plus will get the R2 dash OH alcohol, and this is the aldehyde. Again here this carbon has a positive charge and this one has a negative charge. That means here by transfer of this electron, this positive charged carbon gains electrons. Okay, so that becomes a radical, and this one anion. So this anion accept the electron, that becomes a OH. Again this one accept the electron from the sodium, that becomes a anion. So this one accept the electron. So finally that ester is reduced to alcohol. That is the mechanism of the Bouveault Blanc reduction. And next, coming to the Acyloin condensation. In this Acyloin condensation, here polar solvent is not present. That means here protic solvent is not present. That means there is no proton source in the reaction mixture initially. So here in this case, so this ester molecule RC double bond O ET. Okay, this one. So actually here sodium in the presence of xylene, and that is the first. And in second step, followed by in second step, we have to hydrolyze the mixture. So here you get the RC double bond O, here CH, OH, and here this is R. So you see this one here, by gaining of electron, that becomes a radical. So actually there is no proton source. So if there is a proton source, this O minus becomes a OH, but there is no proton source. So here radical dimerization takes place. So we'll get the dimer product. In this dimer product, the negatively charged oxygen, and this is the ethoxide ion leaving group. Okay, by leaving of this ethoxide group and here reformation of the pi bond, and as well as the leaving of this ethoxide group and reformation of the pi bond. So ultimately we get diketone. Again this diketone accept the electron. Okay, so electrons are transferred to this one here. So the sodium gains electron, that becomes a radical. That positive charged carbon by gaining of electron becomes a radical. And here this one again takes place here. Okay, so here in this case again diradical. So because of this diradical, actually here by gaining of the another electron, so here O minus carbon, here O minus, here alkyl group, here alkyl group, here radical, here radical. So there is a pi bond formation. So as a result we will get the dianion. Okay, so now here in finally this one on addition with water, so this O minus becomes a OH, this O minus also becomes a OH. So here in this case, we will get this compound. So here OH, double bond here, OH and this alkyl group and this alkyl group. Actually this is enol. This enol is converted to ketone form. So finally we will get the hydroxy ketone. That is the Acyloin condensation. The main difference is that there is no presence of the protic solvents. So that's why radical dimerization takes place. We'll get the different products. If there is a proton source, that gives a reduction. Of course, here in this case, here it is a acetylene condensation. So intramolecular reaction takes place. Two ester groups are present in the same molecule here. That dimerization takes place. Okay, internally dimerization takes place. So now here the sodium inyl alcohol, that is of course here ketones also reduced. Here ketones are reduced to alcohol, nothing but Bouveault and Blanc reduction. So you can see internally in this case. Okay, this is the aldehyde molecule. This is the aldehyde molecule. This aldehyde molecule is converted to alcohol. Similarly, ketones also converted to alcohol. Okay, that's it. Now here, this ketone actually in reaction with sodium and xylene H2O. Actually, this ester molecule in sodium xylene that gives a hydroxy ketone. Now here, the ketone in acetylene condensation gives a diol. How it gives a diol? So first of all, here in this case, this one gains electron from the sodium. Okay, transfer of electrons takes place. So here R, and here O minus, here O minus, R, and here R. This is a radical, this is a radical. Two radicals are dimerized. So we will get this one R, O minus, here carbon, O minus, here R, and R. Okay, so dimerization takes place. Next here, followed by hydrolysis, we will get the this diol. This O minus accepts the proton from water. This O minus accepts the proton from the water. We'll get the diol. Okay. So of course this is the starting reactant in phenol-pentoone rearrangement. Okay. So of course here we can use a magnesium also. This ketone on treating with magnesium. So first of all we will get the dimer product. Okay. And this dimer product on hydrolysis we will get the diol. This is the mechanism of that reaction. Thank you for watching. Please share the video and subscribe.